Hello developers, my name is Zahid Bashir and today in this lecture I am going to explain the communication protocols that we used in Arduino or any other microcontroller like Esp32. So we are going to talk about the communication protocols. Okay, here. So our topic is communication protocols. So communication protocols here in Arduino and Esp32. I am talking about the microcontrollers, Arduino and Esp32 or Node MCU. So here's a serial communication. Serial communication, okay. Means we send data serially. So here are three communication protocols that we are used in our microcontrollers to connect our modules, sensors, and other things. Okay. So first of all, I will tell you about that the three protocols are, first one is here. First protocol is UART, RX, TX. So the first protocol here we are using, that is UART, Universal Asynchronous Receiver Transmitter. Okay, so this communication protocol uses RX and TX to communicate with the microcontroller. For example, GSM module. GSM module is the best example here. We are using in order to connect to the GSM module, we are using RX and TX pins. So here the communication protocol is UART, RX and TX. Okay. So after that, talking about the second protocol, that's I2C communication. I2C communication. So I2C communication here means inter-integrated circuit. It is I2C, 2 times I. So here it means integrated circuit. So I2C means inter-integrated circuit. The pins we are using here, that's SCL, SDA. Okay, so 2 pins we are using here, SC and SDA. So the first one is UART and second one is I2C. So first of all, I will give the examples of that, and after that I will explain the third one. So the first one, this one is UART communication. So we call it this is a UART communication, UART, Universal Asynchronous Receiver Transmitter. Here we connect the RX of the sensor. For example, this is our microcontroller and these are our model, for example GSM. So this is GSM, okay. It's a GSM module and it's a microcontroller. So how we connect our UART communication in order to communicate a GSM module to our Arduino or our microcontroller. So here the RX of the GSM module is connected to the TX of the microcontroller, and TX of the GSM module is connected to RX of the microcontroller. It means that the GSM module transmits the data and microcontroller receives the data. And here microcontroller transmits the data and the GSM module receives the data. So that is the UART communication. So here is a cross connection between the GSM module, your module, and between the microcontroller. RX is connected to TX and TX is connected to RX, and you must know that this will be the common. So if you give the external power supply to the GSM module and microcontroller, then you have to common the ground here. If you are using the same power supply between the GSM module and the microcontroller, then you don't need that. If you give the external power supply, then you have to common this thing ground. So ground connect the ground of the GSM or the connect the ground of the microcontroller. Okay, that's it. So that is the UART communication. So examples are GSM module, or GPS module, Bluetooth module. So these are the basic examples that we are using with our microcontroller using RxTX. These are the GSM, GPS and Bluetooth modules. So you can also communication between the Esp32 and the microcontroller Arduino using these pins. In order to communicate between the Arduino, one Arduino communicate with the other Arduino, you can also use this RxTX communication protocol. Okay. So let us move to the second one. This is the example of the UART communication. You can see here. This is our Arduino and this is our GSM module. Here you can see. So here this by using software serial we can make our own RxTX in any microcontroller. So here you can see GSM is connected to this and ground is common. You can see ground is common here, and the power supply is external power supply given to this, and the ground is common between the GSM module and this. Here Rx is connected to TX, TX is connected to Rx, and the ground is common here. You can see, and then he give the external power supply to the GSM module, and also we can give the external power supply here to our Arduino in order to communicate. Okay. We are talking about I2C. Okay. Now I will give the example of this I2C communication here. So here is the I2C communication inter-integrated circuit. So in order to connect the microcontroller to the module, because there are some modules that works on I2C communication. For example, your OLED module also works on the I2C communication inter-integrated circuit. Okay, so here is the best example. You can see it's connected to this, and here the pin number 4, A4 and A5 are using an SCL and SDA. The pin number 5 is the SCL and the pin number A4 is the SDA. A5 is SCL in Arduino and A4 is the SDA in Arduino. Here serial data and serial clock. So here is the examples connected. So I will tell you one thing. By using the I2C, you have the address of the device. You can connect multiple devices on a single pin. For example, if A4 and A5 are the here SCL SDA, so you can connect 16 modules on the same pins. But remember that every module has its own address. For example, if we talk about the I2C display that or I2C OLED module, the address is 0x3C, 0x3D. So every module has its own address. You can connect 16 sensors at a time using I2C communication. But remember, you have to mention the address of every module here. So that is the benefit of using I2C communication here. So the sensors that we are using in the I2C communications are so most of the sensors that we are using, most of the modules that we are connected to our Arduino using the I2C communications are. I will. So first of all, we are using OLED display. So we connect OLED display using I2C communication. Okay. And the other sensor is I am talking about, that is the RFID reader. So also we are connecting the RFID reader using I2C communication protocol here. And there are other sensors like MPU, gyroscope sensor. Also we are connecting gyroscope sensor using SDA and SCL to our microcontroller. Okay. So in short, I will tell you one thing, that if you have any device or any module for the Arduino, you want to connect it on. If you are seeing anything there like SCL, SDA, then you have to think about this is the I2C communication here. So for I2C communication, we have to mention in the code, we have to include a library wire.h. When we include wire.h library in our code, so then Arduino will know about that my A4 and my A4 and A5 pin, these pins are going to use I2C communication. So remember that thing. Whenever you say Rx and TX pins in our module, so that means this is a UART communication. Whenever you see there's a pin is like SCL SDA, then you think that is the I2C communication. So the other communication mode is here SPI, serial peripheral interference. I will talk about later on this, because mostly we don't use in this this protocol in our microcontroller. We don't use this. We are mostly using two communication protocols, that is I2C and UART communication. So I will talk about SPI in the next video, next lecture. I hope you will find this video helpful. If you find this video helpful, then do follow and subscribe my YouTube channel Tech. Inshallah we will meet in the next video. Thank you so much.